Swayam Prabha. Digital India. Educated India.
Okay, hello. So we are again in the another lecture on basic surveying, and this is the lecture number 2 of module 2. Our module 2 is on basic concepts of surveying. Let us go back to our entire structure of the video lectures. We have already done our module 1. We are at the moment talking about module number 2. In module number 2, we have already discussed this particular part in our last lecture. So what we are talking in our last lecture, let's just recapitulate that. We defined the surveying, and also we said that how surveying is of concern to the engineers, maybe mining, maybe civil, any. And basically our aim is to measure the geoinformation. Now we saw many examples. We started from the building construction, the town planning, example of Eurotunnel, example of a bridge, example of a road or route alignment, and using all those examples we understood that how surveying is useful for an engineer. We cannot do surveying, or rather we cannot do any project without surveying, because we need to bring the ground into the laboratory. This is what we saw yesterday. Then only we can work on that ground. Working means the planning, the designing, all those aspects. Once that design is complete, then what we do, we take that design to the ground. So again measurements are involved. So we need to do that thing. So we saw it yesterday, where the surveying is required. Then there are two types of surveyings. One we say surveying, and the other one is a laying out. Surveying means bringing the ground into the laboratory, doing the measurements there in the ground, making the map, doing some other kinds of measurements of geoinformation, and then bringing it into laboratory. Then once it is in laboratory, we have worked upon it, our design and planning other things, we take it out. So that part was called laying out. Then what we discussed? We discussed that surveying is basically about the measurements, and we cannot measure without any reference. I gave you also an example of a child, 1-year child, and his father was telling me that his child is of this height. Then he told me, oh, he forgot to put the other hand, the reference, because child 1 year can't be of this height. So the reference is required. Well, he is of this height, he is this tall. So the reference is very important in any measurement, and we saw that how reference is important for measuring the geoinformation. We need reference for measuring the geoinformation. Now what is the reference? Reference is a mathematically definable system. The geoinformation is on the surface of the earth. Can we use the geoinformation as such, or rather can we use the earth surface as a reference? It is not possible, because the earth surface is not definable. We do not know the characteristic of the earth surface. We can't put any equations for that. So we cannot use the earth surface as such. So what was the other thing? The other thing was, we thought of a surface which is physically existing. That is the equipotential surface, or a surface which is always perpendicular to the direction of gravity. This surface is also called the level surface or void. And the physical surface, which is a void, is the mean sea level or the surface of the water body, because all over the water body there will be equipotential everywhere. The potential will be same. So the surface of the water body makes a surface which we say void. Now we can make use of this void again as a reference, but we had a problem. The problem was the void is also not definable mathematically, because void is basically controlled by the distribution of mass within the surface of within the earth, because the mass distribution within earth controls the way the gravity vector is all over the earth, or the gravity forces. Because the mass distribution within the earth is not constant, it is not uniform, So our joint surface is again mathematically not definable. Nevertheless, one important thing that we saw yesterday, that was about the height or the elevation. In surveying or in any engineering, we mean by height, we say a point is higher than the other point provided the water will flow from this point to this point. So when we are talking of the joint or the level surface, a point which is on higher level surface and a point which is on lower level surface, the water from the higher level surface will always flow to the lower level surface. So we can make use of joint for measuring the heights. So what we did last time, so I am going to draw the surface of the earth here, and the joint in this, let us say, is like this. Here in this part, it is the surface of the sea maybe. So what we can do now, we can refer the heights of points from the joint. So that's the direction of gravity. Similarly here, for this point, we can refer the height of this point from the joint. Also same thing here, the depth. Now what we are talking, we are talking that there is another level surface here, equipotential surface. There is one more equipotential surface passing through this, and as we see that if we put a water droplet here, it will flow in this direction because this level surface is higher than this level surface. So what we say? We say this point is higher than this point by this amount. So the 2 points are separated, or the difference in elevation between 2 points is the separation of level surfaces which are passing through those 2 points. So in any engineering survey, we use the joint for measuring the elevations. Well, when we are talking about the joint, how about the x and y? Yes, we can use the joint for measuring the elevation, but what about the x and y, the positions? So what we did for that, we considered that for our earth, if we can fit an ellipsoid, this is an ellipsoid which is fitting best to the surface of the earth. Now this is an ellipsoid for which we know the mathematical equation, and what we can do, we can project our points on the ellipsoid. So now the distance between these 2 points is actually the distance here in the ellipsoid. We know the equation of the ellipsoid, so we know the characteristic of the ellipsoid. So we can use the ellipsoid for measuring x and y. Now another thing, why we need a reference? As you know that the Mount Everest is the highest mountain in the world. How come? Why not the Alps? Because both of these have been measured using the same reference. If both of these are measured using the different references, we cannot compare these two. So the Mount Everest is somewhere in one part of the world, while the Alps are in other part of the world. So in order to compare these two, we need one single reference which is passing through both of them, and then only we can compare the elevations of these two or the heights of these two. So for this purpose, we need one reference system. Well, we are talking that our reference system is ellipsoidal here, and any two distances that we are measuring between point A and, for example, point B here is the distance along the curvature. But of course, the distance between the point A and B should be measured considering the curvature of the earth, because this is how physically they are. But this is true only if we are talking about a very large extent, large area. This is not true if the area is very small. So for our engineering surveys, because in case of the engineering surveys, our areas are generally smaller. You know, an engineering project, for example, let us say if it is in 20 kilometer by 20 kilometer, then the separation of joint or the ellipsoid or the curvature of the earth from an horizontal plane in 20 kilometer is only 10 mm. I am sorry, not this way, but this separation means the difference in the length of the chord and the length of the arc is only for 20 kilometer. This difference is only 10 mm. What is the meaning of this? The meaning of this is when we are doing engineering surveys or when we are doing the surveying for a small area, we need not to consider the curvature. Why should we measure along the curvature? We can rather, even if we are measuring along the curvature, because the distance which we are measuring on the ground, we can measure the distance by making a line which is horizontal, and we measure this distance along the horizontal. What we are doing? We are not considering the curvature of the earth. Rather, the other way, we are considering our earth to be flat. So, for small areas like this, we can consider our earth to be flat and we can easily carry out the surveying. So, flat means in that case our reference plane for x and y will be like this, x and y, while the z are being measured from joint. I will give you one more example. Here is the earth, as you can see, that is the surface of the earth, and this surface here is the joint, and here is a flat plane which is tangential to the joint at this place. Now, in this example, what we are seeing, if we plot our point, let us say or rather we measure the height of the points, let us say point A and a point B from the flat plane or the horizontal plane. By projecting these points here, we will measure these heights as at the moment what we have seen these two values. So, what we see in this case, the height of A is more than height of B from the datum. What is the meaning of this? The meaning of this is, in this case, the water should flow from A to B, because if you are considering the earth to be flat, we are not measuring elevations from joint, rather we are measuring the elevations from a flat plane, a horizontal plane. In that case, the water should flow from A to B. Well, let us look at the joint or the level surfaces, equipotential surfaces. The equipotential surfaces in this case passing from A will be again parallel to the joint. So, we can draw it like this, and also from B, passing from B will be like this. Well, what we observe, one thing very interesting, if we are looking at the equipotential surfaces, in that case the equipotential surface or the level surface which is passing through B is higher than the equipotential surface from A. What is the meaning of that? The meaning of this is the water will actually flow from B to A, not from A to B. What is the case here? So, what do we mean by this? We mean by this is, if we are taking horizontal plane for measuring elevations, our elevations will be wrong. It might happen that we are giving the elevation to a point, as here in this case A, more than to a point B, despite the water flowing from B to A. So, we must always measure the elevations from the joint, not from the horizontal plane. It says that in all our engineering surveys, we can consider our earth flat for x and y, but for Z we must measure from joint. So, this is an important concept, we should keep that thing in mind. So, this is what all we had discussed last time. These are important concepts, that is why I wanted to repeat these. What we will do today? Today we will start our discussion with some principles of surveying. Now, what is the meaning of this? The principles of surveying means there are some things which we should keep in our mind always whenever we are doing surveying. And in order to explain all those things, what I will do, I will give you one example and we will start with that example. The example is, let us say there is a field, an area, a terrain, and in this terrain it may be of any size there in the ground. There are some rivers here, okay. There are some houses, let us say there are some houses here, there are some roads as well. Okay, we have got some more trees. This is any, any terrain could be like this, while here is the river or a small rivulet. You can just think of any area in your surrounding, just think of that area. Our job is we want to make a map for this area. So, while we are going through this process of making map for this area, we will go through many things which are very important and very basic for the surveying. Now, what those things are? Well, number one, when this job is given to you, I ask you, okay, go to the field and make a map, and I give you, let us say, a tape. Tape means something with which you can measure, and the length of this is 30 meter. Okay, a tape having 30 meter length, I give you that tape and I ask you to make a map of this area. Again, to simplify the matter, let us say this area is of around 100 meter by 60 meter in size. Okay, so it tells you about the extent. Now, you can visualize any area, any garden in your surrounding, and you are given a tape and you are asked to make a map. What will you do? Now, the number one thing which you would like to do, you would like to go to that area, observe it, isn't it? Just have an idea, okay, what kind of my area is, what technique should I use for the surveying? Can I use very good instruments? Should I use very good instruments? That kind of stuff. And can I reach each and every point in my area? Is every point accessible or not? So, that part, the very first part which we do is called reconnaissance. Reconnaissance survey, and sometimes that is also referred as recce. So, you go into the area, you do this recce, and by doing this recce, what you try to do? Well, you try to have an idea of the area. And once you have done the recce, the second thing that comes into the picture is you establish a control network. We will talk about it, what the control network is. Okay. What is the meaning of control network here? Control network means something which will control your entire survey. Now, I will tell you how we will do it here in this case. Let us say for the same area, I am drawing it here again. You sorry, you decide that because you are given only a tape of 30 meter length, and you have to make a map of this area. Is it not that you start measuring from individual tree, okay, the distance between two trees, the distance between two houses, for example, in this area, how will you make the map? It is not that you start measuring the distances like this between the trees, between the river, between these trees, from tree to the river, from tree to the boundary, these individual measurements, no. First, you have to establish a control network. Well, the control network could be, let us say that you establish a control network here, another point here, another point here, another point here, one more point here. I am considering here that it is possible for us to measure distance across the river using the tape. It's a small river and you can do it. Okay? Now, by doing that, what you have done, your network will look like a network of triangles. We'll explain this thing. Let us say that's your network. We will understand very soon the utility of this. You decide about this. This network is also decided at this stage of reconnaissance. You decide about those points which will become your control points. Now, why we want to do it? We want to do it because by establishing these some points and measuring the distance between these points very accurately, what we can do, we can take this skeleton of the area in the laboratory. Now, what is the meaning of that? Once you have gone into the ground, you can do these measurements easily, isn't it? Just you have got the tape, you spread the tape and measure these distances. The only thing is keep your tape horizontal, because we consider our earth to be a small area to be flat. So, by keeping the tape horizontal between these 2 points, I can measure all these distances L1, L2, L3 and similarly. So, all these measurements are known to you. Well, bringing the skeleton of the area into the laboratory, how do we do it? How do we plot that? Well, we do it, let us say we have a sheet of paper here and we want to make our map in this sheet. All right. We start from our very first point. The very first point, for example, let us say was A. So, what we do in our sheet, we locate this A just arbitrarily, A. Now, from A, we know as we had observed in the ground that we have lines going this way. Okay. So, what we do, we draw a line L3 and L2 and again from this point we take an arc. From A, let us say the very first line is drawn here L1. We can measure the angle also, I am not talking about the angle now, and from here we can take the arcs of rest 2 lengths. So, this point is fixed. Similarly, as per the triangulation figure there, we will draw the rest of the triangulation figure. So, what you have done, just by the measurement of these lengths there in the field, you are able to draw this skeleton onto the sheet. Okay. So, the skeleton of the ground is here on the sheet, is on the map. So, what we learn from this? We learn one thing, one principle here, that is establishing control network. Okay. So, in the case of the principle what we learned here is control network. Always before we begin our survey, we should establish a control network, and the control network controls our survey. We will see in a moment how. Now, in our area, what we want to do, we want to measure the individual things. So, to measure the individual things, what I can do now, from any tree, I can drop a perpendicular here, isn't it? So, what I know, along this length at certain x, the distance of a tree is y. Okay. So, what I will do? I will do the same thing here. Along this, at a certain length x, we have a distance y, and at that y we have a tree. So, what we have done? We have now plotted one tree. Similarly, I can plot the other trees also. For example, let us say for this house, I take the measurements of this house from this line by drawing a perpendicular. I measure this x, I measure this y. By measuring this x and by measuring this y, what I can do in my map, this the x and here is the y, and we know there is a house here. So, what I have done, I have plotted the house also. So, now you will start realizing the significance of this control network. Now, some principles which we must follow and we must keep in our mind always. One principle that we say is working from whole to part. This is very important principle, working from whole to part. What is the meaning of this? The meaning is, as we saw also here, what we did, first we mapped the skeleton of the area. The meaning is, first we mapped these distances. We didn't go to the individual features. We didn't start measurements from individual features, individual trees. Rather, we mapped our area first in a big way. We measured these distances very accurately, the L1, L2, L3, L4, L5, all these. We measured them very accurately, and then we plotted them here. We brought the skeleton of the ground here on our map. Okay? So, this is, what we did, we are working first in the whole, the skeleton of the area we are bringing here. We are not bothered at that stage about the features. But in the second stage, now working from whole to part. Now we make use of the control network, these triangulation figures, and then we start plotting each and every detail. Now, what is the advantage of this? Why should we do it? Now, for this principle of working from whole to part, one advantage is accuracy. Why? Now, you take it like this. See, our first control network, the triangulation figure, we measured that very accurately, and we made use of that in order for the plotting. So, these stations or these survey stations are transferred here very accurately because we took utmost care in measurement of lengths. Now, after that, even if we are slightly careless in measuring this y, it does not matter because it is not going to affect the plotting of this house, because these two are two different things, the plot of the house or maybe plot of any other tree here, which we are plotting by measuring the distance here and this distance. So, we can say x here and y here. So, by this I can plot this tree. Again, this is an independent plot. So, this particular plot, it does not affect at all the accuracy of this plot. We may be slightly wrong in measuring this. So, it is not going to affect the entire, the rest of the map. So, our errors are not going to accumulate, they are not going to add up. While if I start doing the mapping, let us say I start doing from part to whole. In doing it from part to whole, what is the meaning? I measure the distance between these two trees, I measure the distance between these two trees now, I measure the distance from here to river, from here to river. You know what I am doing? Any little error which I introduce in measuring this distance will be accumulated in all the measurements which I follow later on. Okay? So, in working from whole to part, we maintain the accuracy, we restrict our survey within certain accuracy. So, this is a very important thing. I can give you some more examples of this working from whole to part, and these examples are from our daily life. Now, one example could be, let us say, the timetable. It does not have to do anything with the surveying, but to understand the concept of working from whole to part. The timetable means, let us say for this lecture I was given a time of 1 hour. So, what I have been given? I have been given, okay, you have got time of 1 hour, 60 minutes. And I have to plan my lecture in these 60 minutes. So, what I do? Well, I have got 60 minutes. Now, I plan my first part of the lecture, second part of the lecture, third part of the lecture. I plan within the 60 minutes only. It is not that I am going to, go over the 60 minutes, because I know my boundary, I know the whole. Had it been the otherwise, I have not been given any time. What I would do, I will plan my first part of the lecture, second part of the lecture, third part, fourth part. Without knowing my boundaries, I might spill over. So that's the idea. That's the very, we should understand, because in our life also many things we do where we implement this principle of working from whole to part. Okay. Now the next principle, we have talked about one principle that is very important, and the control network is a part of that, that is working from whole to part. We discussed one more principle, that is the reconnaissance, observing the area beforehand. The next principle, now here itself, if because what we have done, we have taken utmost care and we measured these lengths. What if some of these lengths are measured with error? What will happen in that case? Let us say this L3. When we measured it on the ground, we measured it with some error. What will it do? If we measure it with some error, it will distort my skeleton of the area. All the measurements later on which I carried out will have some error now. My map will be distorted. So what should we do? How can we avoid this kind of thing? To avoid this kind of thing, there are two ways. Number one, we say redundancy. In measurement. What is the meaning of that? The meaning of that is, if we are measuring a length L3, we should measure it number of times. You measure this length from here to here, number one time, second time maybe from this way, maybe third time, fourth times. So what you are doing, you are taking number of measurements for the same length. Why? Because maybe one of the measurements is wrong. The other measurement is a redundant measurement, but it ensures that your final value, which you will get as the average of sigma L3 I and number of the measurements, what number of measurements you have done. So if you are taking the average of all these measurements which you have carried out for the length L3, your value is more accurate. You are more confident about your value than taking a single measurement. So we should always keep in our mind that we should have redundancy in our measurements whenever we are doing the surveying, whenever we are doing any measurement. The second one is, now here only we carried out all these lengths and we plotted them here. Is there any other way? One way is the redundancy, we introduced redundancy, but is there any other way of checking the accuracy of this system? Well, one more method is possible, and that method is, we say check line. Now what is this check line? Here in this diagram, had we also measured there in the ground, let us say this line. What we are doing? We are not using this line, which I say capital L, for plotting my triangulation figure. I am not using it for that purpose. I am using this check line later on. Once I have plotted my network here, okay, all these points are plotted, then I check the distance between this point and this point in the network, and I compare it with the check line which I had measured in the field. If my survey is correct, if my skeleton is correct, accurate, then the measured line here in the map should be same as the line which was measured in the field. If it is not so, then we suspect there is some error in our skeleton. So always we can have either one or more number of control check lines in our surveying. So we should always go for the check lines. So now you understand what is the purpose of the check lines, so that we can check the accuracy of our work later on. Okay. Now having said this, now we will talk about some more principles which we should keep in mind whenever we are doing the surveying. Well, next thing that comes to our mind is about plotting of the survey. Because so far we were just saying that we have made a map, but there are some things, some important points which are involved, which you should keep in mind whenever you are doing the plotting. What those things are? Here in this plot, before you make the plot, see the ground, look at the ground size. It was 100 meter by 60 meter, huge area. And what you are trying to do, you are trying to bring that into a sheet, you know, the usual side of the drawing sheet. Okay, it's very, very small than the actual ground. So how to bring that ground into this sheet? Well, you know the answer, I believe. You have to talk about a thing called scale. A scale means we want to convert the distances which are large than the ground into the smaller distances for here in the map. Now, about this scaling, what are the scales? What are their types? Number one way of representing the scale is by representative fraction. What is this? We write this representative fraction, also it is referred as RF, as 1:n. Also many times we write it as 1 by n. What is the meaning of this? The meaning of this is 1 unit on map is equal to n units on ground. Well, let's explain it. If our map scale is 1:1000, the meaning is 1 centimeter on the map is equal to 1000 centimeters on the ground. So a distance which is 1000 centimeter there in the ground, we are representing here in our map by 1 centimeter. So this is how we represent the scale. There is one more way of representing the scale, which is called engineer's scale. What is this? In case of the engineer's scale, we represent it as such. For example, let us say we write 1 centimeter is equal to 50 meter. What is the meaning of this? This is another way of writing the scale. It's the same thing, in fact. It's the same thing as the representative fraction, but it's the another way we write it down. Now here in this case, again the meaning is 50 meter there in the ground is equivalent to 1 centimeter here on the map. What you can do, you can easily find the representative fraction for this 1 by n, and you must compute what will be the value of n. How can you compute? You just convert this also in centimeter. 1 centimeter is equal to 50 meter, okay, multiplied by, let us say, I write it in centimeter, 100 centimeter. So 1 is equal to 5000. So the value of n is 5000 here. So we can convert the scales like this. We can convert the RF into the engineer's scale and vice versa. There is one more way of writing the scale, that is called the graphical scale. Well, what is the graphical scale? Graphical scale is, if you are making a map, let us say this is the map, and in this map we have plotted some details, whatever these things are. Okay? So there on the map itself, what we do, we plot our graphical scale. Now what is the meaning of this? The meaning is, here in our map we say, okay, we make a line, and on this line we write, for example, 0 here, 100 meter, 0 meter, again 100 meter, 200 meter and 300 meter. Further, we divide this first one in 10 parts. So each of these is 10 meter. Now what is the meaning of this? What we are doing? We are writing a scale on our map. Now any distance between these 2 points, if I can measure this distance, what I can do, I can bring this distance here if I keep this distance here, for example, this way, isn't it? What I have done, I have brought this distance and kept it here. So, you can measure the distance between these two to be 100 meter plus 1, 2, 3, 4, 5, 150 meter. So, graphical scale is nothing but a graphical way of showing your scale, because here in this case this distance is 2 centimeter. So, what we have done, 2 centimeter is equal to 100 meter. So, we can write the corresponding engineer's scale also, we can write the corresponding RF also. So, the only difference in this case is that we are showing the scale by drawing a line on the map itself. Now, what are the advantages of this? One very big advantage of this is, for example, let us say an engineer's scale is given to you for this map and there is no graphical scale. It is just bare map without having any graphical scale, and the scale of the map is given only by engineer's scale. Well, after some time, the map is made today, and after let us say 10 years, 20 years or so, the map has got shrunk, or maybe it has expanded, because it's a paper or maybe the whatever the material there, maybe with moisture, with time and all this, it may shrunk or it may expand. If it is so, what will happen if this map has shrunk? The distance between these 2 points, which was earlier x, now because it has shrunk, will not remain anymore x, rather it will be minus delta x. Now, if that is the case, and now if you use your engineer's scale in order to determine the distance between these 2 points there in the ground using map. So, what you will do, you will use not x, you will measure the distance between these 2 points as x minus delta x, you will apply the engineer's scale or the representative fraction on this distance. So, what will happen, you will compute a distance which is wrong, because there in the ground the distance is not x minus delta x, rather the distance is x multiplied by the scale, not x minus delta x multiplied by scale. No, this is not, this is wrong, this is correct, but we will do it like this, because what we are measuring on the map is x minus delta x. We do not know what was the x unless we know the amount of the shrinkage. Well, if you have a graphical scale on the map, what is happening there now? Whatever is the amount of the shrinkage which has occurred between these 2 points, we can assume the same shrinkage is taking place in the graphical scale also. So, in the graphical scale, it also shrinks by the same amount. So, what we can do, even if we are measuring x minus delta x, we will measure it here, because this scale has also shrunk by the same amount. The distance which will compute between these 2 points there in the ground will be the same distance equal to this. So, that is one big advantage of the graphical scale. Well, some more aspect. When we are talking about this map, plotting of the map, there is one more important thing which comes into the picture, and that is we say plotting accuracy. What is the meaning of this? In your map, the best that you can plot is, let us say, a dot, and the size of the dot, generally if you are going to be very careful, the size of the dot is 0.25 millimeter. Using the best possible plotting pens, you can draw a dot of 0.25 mm diameter, or even if we can say a line, the thickness of the line is 0.25 mm. What is the meaning of this? Does it convey anything? Yes. Well, when we are talking about the plotting accuracy, there is a dot and the size of this dot is 0.25 mm on the map. what it is equivalent to there on the ground? Well, it will be equivalent to, if you are writing the scale as 1 by n, let us say, okay, where n could be any number. For example, let us say 1 by 100. What is the meaning of this? A dot of this size there in the ground will be equivalent to 0.25 millimeter multiplied by 100, isn't it? So, what is this? What is the meaning of this? There in the ground, if there are two objects, let us say there is one object here in the ground and there is another object. If the distance between these two objects in the ground is, let us say this particular value is, we write it as A, and the distance between these two is B. If B is less than A, what is the meaning of this? If B is less than A, even if we are measuring this B in the ground, can we plot these two objects separately on our map? Once I am plotting the map, I plot my first object, where I plot my next object. To plot my next object, I cannot go here, because the distance between these two is within this line itself. So, my next object will be also plotted like this together, isn't it? So, what I mean to say? I mean to say the plotting accuracy is very important. It depends upon the scale. Depending upon the scale, there will be a certain value there in the ground, this particular value. Depending what the scale is, this particular value will change here. So, whatever is this multiplication, the A value, there in the ground, if the objects or the features are smaller than this size, we cannot show them here in the map. Okay? Or if the separation between two objects, as we saw here, is less than the plotting accuracy there in the ground, we cannot show these two objects separated here in the map. So, we should always keep in our mind that to what extent we should go and map. This is very important, this plotting accuracy. Should we measure very accurately in the ground, as in the previous example? Should we measure these two objects, that distance was B? Should we measure these two objects as separate objects there in the ground, or should we measure them as one? Well, the decision is to be taken by your plotting accuracy. What your plotting accuracy is, what your scale is, because what you do, you compute multiplied by your scale, and any distance, any object, any separation there in the ground which is less than this value should not be measured, because we are not able to plot it. We are able to plot the things which are more than this only. So, this is very important. We should always keep in our mind that what information we should measure in the field that is controlled by the scale. Okay? Having seen all these things, because what we have seen so far, we have seen some principles of surveying. For example, in any mapping exercise, we must do the reconnaissance, number one. Number two, we should establish a control network, because we want to work always from whole to part. And we fix the control network in our area first. I gave you the way we can do it by triangulation. We will see it later on that we can do it by many methods. We establish the control network. We measure it very accurately, so our skeleton is fixed. We can bring this skeleton into the laboratory, plot it. Now we work in parts. We measure the individual objects. Okay? And then while we are doing the plotting, we need to see about the scale. What scale is to be chosen? Well, one more question here. How to decide about the scale? Can you think of some points? Well, the scale will be decided by, number one, size of the area. If there is an area, for example, 10 kilometer by 10 kilometer, and you have a plotting sheet of, let us say, 50 centimeter by 50 centimeter is the plotting area. So, what will be the scale? You know, you can find the scale. But this is not the only criterion by which the scale is decided, size of the area. Many times the significance. What is the meaning of significance of work? When you want to go for higher scale, when you want to go for lower scale. Sometimes you want to go for higher scale, you want to plot at 1:100. Sometimes you want to plot at 1:100,000. When you want to plot at 1:100,000, the meaning is you want to plot a map of entire state, of entire country. Okay, for example, for the entire Uttar Pradesh, we want to show in one map. So we will go for a scale like this, because plotting at this scale, we can bring the entire state in our plotting area. Plotting area is generally a drawing sheet or maybe slightly larger than that. So the entire state come in that. And here in this case, if you are talking about this scale, what we are interested in? We are interested in a synoptic view of the area, not in the details. Because you don't expect to see individual houses, individual roads, individual trees at this scale. But if you want to have a very, very detailed map, you want to see the individual trees, individual buildings, their rooms, everything, you need to go for a scale like this. Now, out of these two, this scale is called large, while this scale is called small. We must keep in mind the value of, because the way we are writing the scale is written as S as 1 by n. So, depending this value of S, the scale is said to be either large or small. If S is large, it is large, S is small, it is small. So, we should know that when we say scale to be large, when we say scale to be small. In large scale and small scale, the amount of the information will be different. Okay. Now, something about, because we are doing some kind of repetition, after talking about this scale, we talked about the plotting accuracy. How plotting accuracy is important, because we can decide what level of information is to be captured there in the ground, is to be measured there in the ground. It is decided by the plotting accuracy or the scale. So, we should know this thing, we should be aware. Then the other thing, whenever we are doing any measurement, we must do the measurements by some redundancy. We should have redundant measurements. Then the other thing, we should always have the check lines, because we want to ensure after doing our work, we can check our work, the accuracy of our work. So, we must have the check lines in our work. So, these are all important principles of surveying we should always keep in our mind whenever we are doing any job. Now, finally, how we plot the details, some little bit about it. This is very simple. Plotting of details. How do we plot the details? As we are doing in the map also, we saw it here in number 10, we plotted some of the details. What we did in that case, for example, for this tree, we measured the distance from this point to this point x, and then from here we drew a perpendicular and we measured along this perpendicular the distance y. So, making use of these two, we can plot this tree. Similarly, there are many ways in which we can plot the details. Now, what these ways are? For example, let us say if we have a line, we know these 2 points A and B, a third point C can be plotted by dropping a perpendicular and measuring this x, as we did in the earlier case. So, this is called an offset.